Okay, so I've copied problem 4 and the two answers that we got. So we need to check and see if these actually work in the original. So for the first one, we're going to replace x with -6. And of course, we have to replace it there also. And we want to know if that's a true statement. So this gives me -12 plus 21. That negative times -6 is +6 equals 3. And this gives me the square root of 9 plus 6 equals 3. And I get 3 plus 6 equals 3. Or 9 equals to 3. And that statement is not true, right? So that means x equals -6 is out as a solution to the problem. It does not work in the original. So let's see about x equals to 2. If I replace x with 2 in both places, we get 4 plus 21. And this gives me 5 minus 2. And I do get 3 equals 3. So x equals 2 is a solution. So at my problem up here, this one does not work. So the answer is x equals 2, or you can write it this way. Okay? All right, let's look at number 5. And again, I have something on the side with the radical that is not underneath. So I have to start by moving that over. So we get the square root of -10x minus 1 equals -3x. Now we can use the principle of powers. We're going to square both sides. It undoes on the left and leaves me with -10x minus 1. And remember, this does mean -3x times -3x. So that is 9x squared. And again, we have a quadratic. And I like to factor with a positive lead coefficient. So I'm going to move these two terms over, get equal to 0 so that we can factor and use the zero factor property. Now my a is not 1, so you can certainly do factor by grouping. But if you look at the numbers for this one, we can kind of tell. If I need factors of 9 that make 10, then we're going to need this to be 9x and this to be x. And the only thing that will make 1 is 1 times 1, right? And then both of these will need to be plus. We use the zero factor property. And I get x is equal to 1/9 and x is equal to -1. And I bet you can see what the issue with this one is going to be. Nobody wants to try to plug that -1/9 in, right? So hopefully you've learned me well enough by now that if there is something like this on the test, there certainly won't be a lot. I try not to overload on the hardest of the problems. But if we want to check x equals -1/9, remember we can certainly make use of our calculator? I most certainly would. You don't have to show a lot of steps here. That's, if you put that whole thing in the calculator, it doesn't bother me. I'm going to show a couple of steps, and it's just because I want you to be able to check as you work along. So that first term is just going to become positive 10/9 minus 1, and then it's minus 1/3 equals 0. And I did enter square root of 10/9 minus 1 in the calculator. That just gave me 1/3 minus 1/3. And we know something minus itself is 0. Okay? So don't make the check complicated. Show me the substitution. Use your calculator to show me the two sides are equal. Of course, we do also have to check the x equals -1. So if I replace x with -1, on this side, that's going to be 10 minus 1 is 9, minus 3 equals 0, and this does give me 3 minus 3 equals 0, and the two sides are equal. So both of those are solutions, and you can give the answer in either format. Okay? I think we just got one more of these. And of course, it's easy to spot the difference for this one, right? For this one, the left-hand side and the right-hand side are both under a root. They are isolated, so we can go ahead and use our principle of powers. This time, the roots are going to go away on both sides, and we're just left with a linear equation. So I'm going to move my x terms together, move my numbers together, and I get x equal to 3. Then we just need to check. Replace the x with 3. So on this side, we get 36 minus 1 gives me square root of 35. And on this side, if you put that in the calculator, whoops, I'm sorry, you also get, I multiplied the 3 and 6 in my head. You also get the square root of 35. Since we got a true statement, x equals to 3 is our solution. And you can write it either way.